Hi everyone, welcome to AI Ignition. My name is Beena Amanat and I lead our global Deloitte AI Institute. And today on AI Ignition, we are joined by Eric Siegel. He is a best-selling author and a former Columbia University professor and the founder of Gooder AI. Eric, you have a fascinating journey. Can you share with my audience about a little bit about yourself and your journey so far?
Sure. I've been in the field of machine learning for more than 30 years. I was a professor at Columbia University, where I also got my PhD focused on machine learning. Um, and I've been an independent consultant for 20 years in the field, and now the co-founder of Gooder AI as of a year ago. Um, so my trajectory has sort of broadly been like I fell in love with the concept of AI as a kid. It's where I landed, although I'm now really questioning what the definition of that field is. But I did very much fall in love with machine learning about 33 years ago. And I'm still just as excited as ever about that technology. But what I've come to in more recent years is the question of, well, is it actually realizing value? We're creating potential value with it by creating models that predict, but are we capturing that value? Well, it turns out that oftentimes these enterprise projects fail to do so and get to that sort of last mile of value capture. So that's been my main focus in recent years.
Yeah, and you've also been a leading voice in the field of predictive analytics for many years, 33 years. You've written a book on it. Can you start by providing background on predictive analytics, the field itself, and why it has become so crucial in today's world?
So predictive analytics is sort of the original enterprise AI. When you're talking about business applications of what people might call AI, it was pretty much predictive for the most part up until a couple of years ago with the unprecedented advent of generative AI.
Mhm.
But predictive analytics is learning from data. That's the core. So you could also call it enterprise machine learning or predictive AI now to differentiate it from generative. Learning from data to predict, to determine which individual is going to click, buy, lie, or die, commit an act of fraud, turn out to be a bad debtor, be a good place to drill for oil, be a satellite that's going to run out of battery or a train wheel that's going to fail. At that level of detail, per individual items or cases at that level of granularity in order to drive operations, because all of our existing large scale operations are composed of many kind of micro decisions, micro relative to the overall enterprise. So determining who's going to click, buy, lie, or die directly informs who to contact, mail, investigate, incarcerate, set up on a date, or medicate. So turning this is the most actionable thing you can get from data in terms of enterprise operations. This is the technology you turn to improve your existing large scale operations.
Yeah, yeah. And my exposure to predictive analytics. So I studied AI 30 years ago, a while.
Hmm.
And I think that's very old. But things have, much of what we did then was more theory, right? It started becoming real in the last 20 odd years.
Hmm.
Once social media came in and we had access to big data. And my exposure to predictive analytics, early exposure was on, predicting jet engine failure, predicting how much power would a windmill generate, and so on. So, but it's so applicable in every part of the business, right? It helps businesses function better and more efficiently. Now, you've also been in consulting, but also in academia.
Hmm.
And what are some of the biggest challenges that you see companies face when trying to bridge the technology business gap in AI deployment?
Yeah, I mean, that gap is tough. And
Yes.
it really manifests in terms of implementing these types of predictive use cases, these value propositions. And to be clear, if we want to call it predictive AI to differentiate from generative, we're alluding to two major categories of use cases of value propositions more than any particular type of machine learning. Not
Yeah,
so
yeah.
much the technology, but it's how it's used, right? So in these predictive cases where it's directly informing pretty much all the main large scale operations that we conduct. The problem is actually getting that change into place. So the science is
Yes.
good, the data scientists are good, and the
Yeah.
machine learning software is good. It
Yeah,
develops
yeah.
a model that predicts. That's the cool part, right? That's the rocket science. That's the thing that we fall in love with originally as data scientists, which is the ability to ascertain patterns or formula from some limited, even if it's big, it's relatively limited number of examples, historical
Mhm.
examples or what have you, or labeled examples from which to learn. and it derives something that then will hold in general over new, previously unencountered cases and situations. And in that sense, has truly learned something, not just discovered a pattern for this data, but that holds in general. It learns something about the world that's therefore very, very potentially useful and valuable. But only do you capture that value if you act on it, if you deploy it, implement
Yeah.
it, operationalize it, actually change those operations with the predictions. And by prediction, let's be clear, we're talking about probabilities. We don't have a magic crystal
Yep.
ball. So what is developing, what is generating or calculating on these per case bases is a number between 0 and 100 or 0 and 1, right? The next best thing to a magic crystal ball, some kind of a probability saying, well, how likely is it for this case? And how about for this case? And how about for
Yeah.
this case? So that you can decide where do you draw the line and which of the individual customers who should be contacted that you spend $2 for targeting marketing, the transactions that should be audited or blocked as potentially fraudulent. So you're driving these decisions based on those probabilities. That's a pretty big fundamental change that involves, yes, the idea of a probability, which in and of itself isn't that complex, but it's such a big paradigm shift that actually getting it deployed, right? Actually
Hmm.
getting the organization and stakeholders to greenlight at the end of the project, well, it's not the end of it once you've actually deployed it, but sort of the culminating point of the initial project. Let's actually get it deployed. And more often than not, it turns out that with new enterprise machine learning projects, it fails to deploy. The
Yeah.
stakeholders who've not gotten their hands dirty in the sense of getting involved with semi-technical understanding get cold feet. So you've
Yeah.
got to dirty their hands in order to keep their feet warm so that it will get authorized, you'll actually deploy, right? So the reframing that we need is to consider these business operations improvement projects, which does
Yes.
not roll trippingly off the tongue the same as AI, doesn't
Yeah.
sound nearly as sexy, but in a sense, it really is because it's the value, right? That's where you're
Yes.
realizing value. That's where you're actually improving the way operations work. So currently, the sort of, if I was going to psychoanalyze ourselves, it's like we're more in love with the rocket science than the launch of the rocket.
Isn't it always true though that it's always
Well, not in the case of rockets, right? In general, we're more in love with it's the launch of the rocket that's the really exciting part, right? We need to transfer that same mentality over to these projects.
Yeah, but you need that some shiny object, a shiny term to almost drive that change, move the technology forward. Um, eh, eh, you
Yeah.
know, if you call like AI, what it was statistics a lot for a long time. What was used in the real world was statistics. But if it was called statistics, it wasn't as sexy as AI. But
No,
what happened?
statistics is 3 syllables, and by the time you're halfway done the
Yes.
second syllable, everyone's already fallen asleep. Yeah.
Yeah, yeah. So, you almost need some kind of a trigger or some kind of a
Yeah.
word that helps you move forward. And, a successful AI deployment is not just about the technology, it's also about the people, the process, the changes, the
Yeah.
change management that goes with it. Now, Eric, you've also been in academia as a professor. How has that shaped your approach to deploying machine learning in the real business world?
Yeah, so my first foray into academia was a lifetime ago, really turn of the century at Columbia University. But more recently, ending about a year and a half ago, I spent a year as a visiting analytics professor at University of Virginia Darden School of Business. So, right, that kind of represents my character arc, moving from
Yeah.
technical to the business department, right, where we care about the actual operationalization, the actual creation of value. And it was during that professorship where I really developed the ideas, the paradigm of what I call BizML, the business practice for running machine learning projects successfully through to deployment.
Mm.
So that was sort of the purpose of me going to Darden, was to develop the ideas and put it together in a way that not only speaks to the techies but to the business people. And that's the whole point, right? I mean, the thing
Yeah.
that's often missing more than anything, these projects, if you're listening to us right now and you're not a data scientist, you're what we need.
Mm.
You're what these projects need more than anything, more than better technology and data scientists with more training. Even I'll dare say more than bigger data. We
Mm.
need people who have ramped up on a semi-technical, totally accessible understanding in terms of what's predicted, how well, and what's done about it. And that trio I'll probably try to repeat again just that basic understanding that defines the project and its value proposition.
Mm.
Ramp up on that basic idea. It's exciting, interesting, pertinent, and not very technical. So that then you can participate end to end across the steps. For example, as I formalized it with BizML, 6-step practice,
Mm.
end to end across the project with deep collaboration with the techies, the tech biz collaboration, the data scientist and their customer, the stakeholder, the person in charge of the operations meant to be improved with the model. So let's get that collaboration going. That's the message I'm really trying to get out there.
It's amazing. And you also have an earlier book, Predictive Analytics. Tell me a little bit about what prompted you to write that book and what are some of the takeaways from that book that came out in 2016?
The purpose of the book was like, look, there's lots of sort of pop science books out there for economics and the Malcolm Gladwell books. Those are fun, right? Why shouldn't there be one also about my field and our field, machine learning, right? Which should totally be understandable to my uncle, to anybody who's not a data scientist, right?
Yeah.
And it's of interest. It affects everybody every day. So let's put it out there and make it clear what the value proposition, which for any given application or use case is basically what's predicted and what's done about it. And let's talk about why it's valuable. So sort of two of the main concepts are what I call the prediction effect and the data effect. And the prediction effect is that a little prediction goes a long way, right? So we don't have incredible magic crystal balls, but
Yeah.
we can predict better than guessing. And it turns out that that's generally more than sufficient to render a dramatic bottom line improvement to large scale operations. So it's putting
Right.
odds on the numbers game that is business. So I call that the prediction effect. And the
Yeah.
data effect is sort of the whole point. It's data is always predictive, right? When you get your whatever data, the big data movement was about, hey, look, we've got a lot of data just as a side effect of conducting business as usual and recording all these transactions and happenings and what have you. Data is a recording of the collective experience of an organization. It's a long list of historical events in a sense. So
Yeah.
it's experience from which it's possible to learn. And it turns out that, yes, you will find these correlations that are predictive, that are the building blocks for these predictive models. You can sleep well at night knowing that at least the tech side of this stuff is going to work. Once you start doing the analysis, you're going to derive these models that really work well.
How much do you think this, in from your purview, how much has this field evolved, changed? How much have businesses changed, evolved in the last 10 years, you would say?
Well, I think tremendously. I think it's much
Yeah.
more pervasive that there are predictive analytics projects. What's happening now with generative completely changes the conversation as of a couple of years ago. I would say the jury is still out about whether that improves the viability and leveraging of the predictive use cases,
Mm.
which are older, but not old school. Most of its value is generally
Yeah.
untapped. And I've been out there saying, look, we should probably, most companies, it depends on the company, should probably be investing and investigating into predictive use cases at least as much as generative, because it may not be as amazing, but it's
Yes.
oftentimes more valuable. It's how you improve existing large scale operations. They're really apples and oranges, but generative tends to suck the oxygen out of the room and is taking away from predictive budgets probably a bit too much, in my opinion. Um, but more generally, because it's a longer time frame, you asked about sort of a 10-year span. Things have changed dramatically because now
Yeah.
all companies, it's sort of even before generative, it's like, well, of course we're going to do something predictive if we're a large enough organization, or at least have large enough operations worthy of this type
Yeah.
of endeavor. Um, and so even though surveys and industry research are both that I was involved in, for example, while at Darden and others, are showing that more of these projects fail to reach that deployment than succeed, even when they were intended for deployment. Even though, even if it's 20% that succeed, 20% of a lot of projects is a lot. The bread
Yeah.
and butter of the conference series I've been running since 2009, Machine Learning Week, is about those proven value-driven use cases across companies, all the different presenters at the conference. There's a lot of success stories out there, even if there may be even more failures so far, because we
Yeah.
haven't quite made that sort of paradigm adjustment.
Yeah, and I was going to ask you what prompted you to start Machine Learning Week conference. You alluded a little bit on, how do you make it accessible to everybody and especially the business folks? What prompted you to start these events and conferences?
So Machine Learning Week was originally called Predictive Analytics World until a few years
Ah,
ago, and we started in 2009. As a former academic, I was teaching these seminars, but I was doing it aside another conference, and those producers were like, "Hey, there should be a predictive focused conference in and of itself." So at the time, we were the first non-research,
yeah,
event focused on commercial deployment of predictive models. And something that's differentiated us since then than the majority of machine learning events is that we're not just a technical event. So instead of having sort of 95% of the audience data scientists, it's more like 60%. And we have a whole business focused track, the biz ML operationalization track. So we sort of have the business focus. We've got business stakeholders and newcomers, as well as plenty of sessions for the techies. So that's sort of the way Machine Learning Week works.
yeah. You're also the co-founder of Gooder AI. What
Yeah.
are some of the challenges and opportunities you have encountered in leading a company focused on AI? There are so many AI companies.
Mhm.
What are some of your lessons?
Well, the vast majority of AI companies, or at least AI startups, are verticals, right? So it's like, here's a
Mm,
particular use for a predictive model or
yeah,
for generative AI, a large language model, or what have you. We're horizontal. So
yeah,
instead of being like, oh, we're dealing with AI challenges, the whole inception of the company is to deal with those challenges. The challenges we've already been talking about today, but a little more specific. It's
yeah.
about the metrics. It's
Mm,
about determining how good is AI, how good is this model, not just in terms of arcane technical metrics, which are generally the only thing that data scientists deal with during the
yeah,
development of the predictive model, but
yeah.
also really straightforward business metrics like profit and savings. And by
Ah,
turning that corner, which is gravely needed, a fundamental shift that's been outstanding now for decades, we can create the business user console of like, okay, I'm trying to target this fraud detection. Well, how do I use this model? And if depending on how I use it, how much how much money is it going to save in terms of more fraud captured and or fewer disruptive holds of transactions or fewer audit staff people spending time investigating, right? So there's all these trade-offs. It's just the arithmetic. It's not the rocket science, but it's very
yeah.
particular arithmetic that requires a specialized visualization so that it
Mm,
makes sense. It's been presented in terms of business metrics. And we've made that much needed move from these technical metrics to provide the visibility so business stakeholders can actually get their hands dirty in that sense, see something concrete, see it in terms of the straightforward KPIs that are the lingua franca of business, and then it becomes plausible to greenlight the deployment.
yeah, yeah. And with the rise of AI, obviously the topic around ethics of AI has also gained a lot of prominence in the past few years. What is your approach to addressing the ethical considerations of machine learning when looking at making it more trustworthy?
So here's the issue. When you're doing these types of projects that are going to drive large scale operations, you're not just streamlining business and optimizing the number crunching, you're governing in a sense. Lots of the
Mhm.
time, for a lot of these projects, the decisions that are human facing, um, whether in healthcare, credit assignment, or even legal applications, are they drive consequential decisions. So literally, are you going to get a loan? Are you going to be released early on parole from prison, depending on a prediction of recidivism, which is will you be
Yeah,
incarcerated again upon release? Um, so the way these models manifest, the ethical considerations come in not so much whether they get it wrong, because they will get it wrong. Again, there's no magic crystal ball. And if we had
yeah,
no computers and it were humans making these decisions all the time, they'd also get it wrong. So by using data, hopefully we're getting it wrong less often and right more often, and
yeah.
demonstrably so in many cases. But there's a secondary issue, which is how often do these costly, unfair decisions where someone's wrongly incarcerated for additional time or wrongly denied a credit card application
Yeah.
or housing or any of these really consequential decisions, how often are those what are called false positives taking place more often for one group of individuals than another? So it comes down to distinguishing by protected groups
Yeah.
like race, national origin, and gender. And looking at the false positive rate, and that's called machine bias. That term kind of comes from an article of the
Yeah.
same name in ProPublica, which is the most often cited with regard to that type of issue.
Eric, thank you so much for joining the show today. And thanks to our audience for tuning into AI Ignition.
Thank you, Bina. It's been great talking to you.
Be sure to stay connected with the Deloitte AI Institute for more AI research and insights.